Page 563, lesson number 2, writing equations in the form y equals mx plus b. So last time we looked at what that equation means, and now we're supposed to be able to write equations. So write the equation of a line passing through the point 0, 2 with this particular slope. So the way we want to approach this is if we are writing an equation of the line in this format, then we need to know m, which is the slope, and b, which is the y-intercept. So this is the slope. They gave it to us. And if you think about what this point actually means, if the x value is 0 and the y value is 2, then conveniently this actually is the y-intercept that they have given us. If you recognize that, then it's very quick for you to write the equation of this line. You're going to have 5 halves x plus 2. In class example number 2, they've just given us a picture of the line, and they want us to state the slope and the y-intercept. So if we look at line 1, here's line 1 over here, we are looking for a slope, which means we need to find points that are conveniently right on the dots. So I'm going to choose these two because they seem to be convenient for me. And I can count the rise, which is 1, 2, and the run, which is 1, 2, 3, 4, 5, 6. So if I reduce that, the slope is going to be 2 over 6, which is 1/3. Now let me just verify that it is indeed a positive slope and that I didn't mess up. Is it a negative slope? No, it's a positive slope, and I know that because it rises to the right. So the slope is indeed 1/3, and the y-intercept can be read right off the graph. Looks like it's right here at -4. So the equation of this line is y is equal to 1/3 x minus 4. For line 2, let's just check that slope. So I need to find two convenient points. So I'm going to choose this point, which is quite convenient. And what's another convenient point? Oh, over here. There's one here. And if I'm looking at the rise, it's 1, 2, 3. And the run is 1, 2. I'm just going to double check that I have the correct sign for this slope. It seems to be falling to the right. So I can tell that this is actually a negative slope. So -3/2 is our slope. And our y-intercept is easily read off the graph in this case. So that's going to be 2. And our equation of the line is going to be y is equal to 3/2 x plus 2. Class example 3 gets a little bit trickier because they have given us clues, and the clues have some distractors that we don't care about. So determine the equation of the following lines. It is parallel to this line. So if it was parallel to this line, that means it has the same slope. It has a slope of 1/3. We don't care about the 4. We know that it was parallel to this. So by giving us that clue, they have given us the slope of the line. The same y-intercept as this. So you'd have to identify the y-intercept, and you'd say the y-intercept is -7. Well, what about the 6? It doesn't matter. We don't care about that. They've given us this equation as a clue, and we need to extract the relevant information. If they have the same y-intercept, then the y-intercept's -7. So the slope of our line, the one we care about, is not this one. It's not this one. It's built from the clues. Y is equal to 1/3 x minus 7. In part B, they're asking us to do a completely different line. It says that the line passes through this point, and it is perpendicular to the line that's joining these 2 points. Now, conveniently, this point happens to be a y-intercept. So we can simply say that our y-intercept is the same, which is going to be 9. That's convenient. What is not convenient is they have not given us a slope or an easily read slope. We actually have to calculate this slope using the slope formula. So we're going to do y2 minus y1 over x2 minus x1. And I'm going to make sure that I label these so that I don't accidentally do something wrong and switch my coordinates. So y2 is 0, minus y1, -6, and x2 is -5. minus x1, which is 2. So we're going to have positive 6. Those two negatives cancel each other out over negative 7. So negative 6/7. Now, is that the slope that I'm interested in? No, because it says that it's not the same slope. It's not even parallel. It is perpendicular to the slope. So the slope that I actually care about, that's perpendicular to this one, is the negative reciprocal. So I need to flip it and change the sign to get the slope that we actually care about. So the last step is to write the formula or the equation of the line that we care about, which has this slope and this y-intercept. That was a very tricky question because you have to piece together the clues in order to get the slope and the y-intercept. We are going to skip question 4 because graphing calculator is not going to be part of our curriculum this year. If you go further down the page on page 564, we're looking at this example with horizontal and vertical lines. State the slope and the y-intercept of horizontal L1 shown on the grid. So L1 is right here. There's L1. And it's asking us to state the slope. So if we're looking at 2 points on slope on this line L1, if you're looking at the rise, we actually have a rise of 0 between these 2 points if we choose those 2 convenient points. But we have a run of 2. So if you do the rise over the run, you just end up with a slope of 0. So we'll say that the slope of this line is 0. And actually, the slope of any horizontal line is going to be 0. Let's see, is there a y-intercept of this line? There is. It does intersect the y-axis right here. So the y-intercept is 4. So if they want us to write the form y equals mx plus b, we can do that. We can say y is equal to 0, x plus 4. But if you simplify that, you'll end up with a simplified form of y is equal to 4. That is the equation of the line. I know it doesn't have any x's in it, but what this equation is saying is that no matter what x value you pick on this line, all the y values are 4. Look, this particular coordinate is like 2, 4, and this one over here is negative 5, 4. And no matter what coordinate you pick along this line L1, the y coordinate is 4. And that's why the equation of this line is y equals 4 without x. X doesn't even matter, no matter what x value you pick along this line. Example C asks us to predict the equation of L2. Without having to go through all of that work determining the slope, calculating it, can we just guess what the equation of L2 is going to be? We can guess that it's going to take this format. Y is equal to some number. What is that number? Well, if you look at the points along this line, what is the y coordinate of every single one of them? It is negative 6. So you can simply use that as your equation, and that's a quick way to determine it if you know what you're doing. We're not going to use a graphing calculator to verify it. Part D, state the slope and the y-intercept of vertical line L3. So L3 is over here, and if we pick 2 points on the line, let's say these two, we can get a rise of 3 and a run of 0. So we can try and divide these two. What is 3 divided by 0? That is undefined. So the slope of a vertical line is not 0. It is undefined. So that's our slope. Does it have a y-intercept? Let's see. So if I'm looking at this, I'm looking to see if it ever crosses the y-axis, which is here. And it looks like if you follow this line, it's never going to cross the y-axis, so that there is no y-intercept. So if we have no slope and we have no y-intercept, then we cannot use y equals mx plus b. There's no slope, it is undefined, and there is no y-intercept. So that's a problem. We cannot use this format to write the equation of a vertical line. But we can still write an equation of this line using the pattern that we saw before. By labeling the points, you can see a pattern. The coordinates of this point are -3, comma 3. The coordinates of this point are -3, comma 0. The coordinates of this point are -3, comma -3. So what do all these points have in common? Well, they have an x value of -3. No matter what y value you end up choosing, you're still going to have an x value of -3. So the equation of this line can be written as x equals -3, no matter what y is. So notice the difference between these vertical and horizontal lines. A vertical line has an equation of x equals something, and a horizontal line has an equation of y equals something. Keep that in mind. For example number 5, it says determine the equation of the line through a particular point and parallel to the y-axis. So to explain this one, I'm actually just going to draw a little sketch here. And the point that they've given us is -2, comma 8. So I'm just going to estimate -2 is here and 8 is here. So here's the point I've been given, -2, comma 8. And in part A, it says that the mystery line that I'm talking about is parallel to the y-axis. So if I draw that, I could draw a line that looks like this, a vertical line. So if it's a vertical line, I learned in the previous example that a vertical line is going to say x equals something. Well, what is that x going to equal in this case? Depends on what the x coordinate is over here. And the x coordinate is -2. So that's the equation of this line. In part B, it says, what if it's parallel to the y-axis? So I could draw a line like this that's parallel to the x-axis over here, like it says. And what's the equation of that line? Well, in the previous example, we said that horizontal lines will have the equation y equals something. And that something in this case happens to be 8. So that's the equation of those two lines. Before I end this video, I want to talk about one more kind of example, which is writing the equation of a line that joins 2 points. Can you write that in y equals mx plus b format? So now some students might tackle this problem by saying, well, maybe I can draw a picture, 2, comma 4, and -3, comma 1, and maybe I can figure out the slope from there and the y-intercept. Now, that may work if you have a ruler, but the y-intercept may not come out to a nice number. So then we're going to have to do some algebra. What if the y-intercept is actually a fraction? So I'm going to show you how to do this algebraically using the slope formula and solving for b. So first of all, to determine the slope of this line, we're going to have to use our slope formula. So here's x1, y1, x2, y2. Then we can do y2 minus y1 over x2 minus x1. If we do that, we're going to get -5 over -5. So we have a slope of 1, which is convenient. So far, if we wanted to write our equation, we could simply write it as y is equal to 1x plus b. But the question is, what is b? Luckily, it's actually quite easy to solve for b if you know literally any point on the line. All you got to do is plug in the points for x and y, and you can solve for b. So I'm just going to choose this one because I like working with positive values, so this one's going to be easier to do. I'm going to plug in for x and y, and I'm going to solve for b. So 4 is equal to